That last little bit of AP Stats, Inference for slopes. Didn't get to it? We got you covered. Stay tuned. Hi, welcome to CED 9, the one unit that sometimes we skip in AP Stats. So if you haven't had a chance to run through it, hopefully you'll find this helpful. The notes are down below. While you're down there, like, comment, subscribe, hit the little bell so you know every time I post something new. And that's going to be particularly important because I'm going to be redoing my 3-week review course. And so I'm going to break it down into the CED 1, 2, 3, 4, 5, 6, 7, 8, 9, and then talk you through all of that and revise the videos from the previous one. But I'll have the link to the other one in case you're doing it chapter by chapter. Anyway, let's get going with this. So what we're going to be doing here is we're talking about inference for quantitative data. So we're going to talk 2 variable stats. It's all going to be about slopes. We're going to hear like regression lines and things like that. So for the distribution, what we ended up doing was this. We talked about how there was a teacher put their kids randomly assigned and they wanted to see if, what does row affect how they do. So here what they ended up doing, everybody got assigned a random row and a seat. And then these are the exam scores that they had. So a couple of things, and most of this you should be able to go through and do from what you did in chapter 2 in unit 2. So if you want to pause it here and run through it, that's fine. Otherwise, just follow along. So the first thing is that this is obviously going to be an experiment, not an observational study, because there was a treatment that went. They assigned a row to everybody. So the row is the treatment, and then the response variable is going to be your score. And the reason why it's good to know there was random assignment is because that way we can show causation, that the seat that you were sitting in was actually affecting what your score was. So we went through 2 quantitative variables. Some discussion sometimes in my class was about, well, is that first one really categorical because it's 1, 2, 3, 4? And since you can measure it, it's like saying, how many hits did somebody have in a baseball game? All right, you can't have 1.5 hits, so you're going to have integer values for there. So this would be fine for that. So then we've got the explanatory variable, as we kind of talked about before, is your row, and then obviously your score is going to be the response variable. I've been saying a lot. My apologies. The staplet down here makes this graph, and when you run the staplet, you can see obviously the different rows are all stacked on top of each other, which is fine. If you remember before, then what ends up happening is we get this least squares regression line like this. If you're running it on your TI-80 calculator, you're going to notice that you can run either AX plus B or A plus BX. This is kind of the standard linear regression line that you're going to end up running. And if I look at Staplet and ask it for it, it will give me this down here as my least squares regression line. Now, as you saw from the title, we're going to be talking about slopes. That's going to be the most important thing so we can see how fast things are going, et cetera, et cetera. So this right here is our slope, negative 1.517. And so in context, that means that for every row that a student moves back, their exam score is going to drop by 1.517 points. So the further back you go, the more points you're going to lose off your exam. Okay, so we're going to go ahead and go over and see what this looks like. Now, the Staplet has a neat little feature down here. So if we run down, it's here in the bottom, you can run down here and say perform inference. And so we're going to choose simulate sample slopes. Okay, and so for my class today, we had roughly 25 people in there. And so we're going to type in 75 samples so everybody did 3. And if I click on add samples, that's what I get. Now, obviously, that's not tons of what's going on there, but it's still enough to be able to see, okay, let's take a look and see what's going on. And you can kind of see some stuff way on the outside, but we're getting more stuff in the middle. And so if we, let's say, even just jump this up and add another 500 in here, you can start to see what this looks like. And it starts to very obviously become that it starts to look, oh my goodness, it looks almost normal, which of course it will be. And that's where we're going with this. Okay, so if we take enough samples, if the sampling distribution ends up of your slopes of your least squares regression line ends up being normal as you go through and do it. So anyway, that's how we go through and start to kind of get a sense of how sampling distributions for slopes will work. We'll go through the formalization here in part 2, link down to that below, obviously, and when you have a chance, we will see you over there.